Hey everybody, welcome back. This is lesson 5-6, the quadratic formula. The objectives for today, you're going to be able to solve quadratic equations using the quadratic formula, and you'll be able to classify roots using the discriminant. Your vocabulary for today is discriminant. All right, so you have learned several methods for solving quadratic equations: graphing, making tables, factoring, using square roots, and completing the square. Another method is to use the quadratic formula, which allows you to solve a quadratic equation in standard form. By completing the square on the standard form of a quadratic equation, you can determine the quadratic formula. So I just want to show you briefly this page about how we come up with the quadratic formula. Basically, when we start out with an equation that we've seen quite often, like this one right here, 3x squared plus 5x plus 1 equals 0. It's written in this same form, ax squared plus bx plus c equals 0. And our goal is always to figure out what x is when y is 0. What is x when y equals 0? So we've come up with a lot of different ways. Like I said in the slide before, we've used graphs, we've used tables, we've used all sorts of things. And today we're just going to figure out a way to solve this whole equation for x. And I'm not going to go through it step by step with you, but basically, if you'd like to turn the video off and take a look at this, what we do is we first of all divide everything by 3, and if it was just in the ax squared plus bx plus c form, we would still divide everything by a so that there's just a 1 in front of our x. And then we would subtract and get our constant on the other side. And same thing over here, we're subtracting to get our constant on the other side. And then we use the formula that we did to complete the square. Remember, we took b divided by 2 and squared that. Okay, so that's going to be the same thing, and add that to both sides just like we did in completing the square the other day. And then we factor it out and take square roots and everything. And in the end, we end up with x equals this equation. And this is the quadratic equation. And I need you to memorize this equation because you're going to need to know it. And so I'm going to sing a little song for you, and I'm going to sing it all during the video because I want you to get this memorized, all right? So you're going to need to memorize. You cannot write it on a card for your test or anything. You just have to have it memorized. So we're going to get started, and every time we see it, I'm going to sing it for you, and so you'll be able to sing it and remember it, okay? So it goes like this. It goes to the tune of Pop Goes the Weasel. Goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, there you go. So let's get started with it. All right, the quadratic formula, if ax squared plus bx plus c equals 0, and a cannot be 0, then the solutions or roots are the following: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So every time we see this today, we're going to be singing that song. You can use the quadratic formula to solve any quadratic equation that is written in standard form, including equations with real solutions or complex solutions. And remember, we talked about complex solutions. Those are the ones with I in it, our imaginary numbers, okay? So I just wanted to point out one thing where this says where x can't equal 0. If x equals 0, then we would not have an x squared, and we would just end up having a linear equation, and so that totally does away with it being a quadratic equation. All right, let's move on. Okay, let's try example 1. It says find the zeros using the quadratic formula. So in order to use the quadratic formula, we need to know what our A, B, and C are. So A is going to be 2. We get that from right here. B is negative 16. That's right there. And our C is 27. Okay, so now the question says, find the zeros of f of x. Okay, so we want to set f of x equal to 0. So we're going to say y equals 0. Now, why is that? Well, when we look at a quadratic equation, when we graph it, the graph sometimes crosses our x-axis when y equals 0. All right, so we're trying to find if the quadratic crosses my x-axis, where does it cross? So if I set y equal to 0, I can find out what x equals. Okay, so here is my equation set to 0, and now I'm going to write out the quadratic formula. And you must write out the quadratic formula every time you are asked to do a problem with the quadratic formula. I want it written out, so let's get it memorized, okay? So here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so you got to have that memorized. So now, once we've written the quadratic formula out, we're going to substitute our for each of our letters. So here we say x equals negative b. Well, I see that b is negative 16, so I'm going to say negative b plus or minus the square root of b squared, which is negative 16 squared, minus 4a C, and C is 27, all over 2A, and A again is 2. Okay, there you go. So once we've done that, the next thing we need to do is just simplify it out, and I've kind of already done it for you. So our negative B, which is actually negative 16, okay, negative and a negative is a positive 16, plus or minus 16, negative 16 squared is 256, minus 4 times 2 times 27 is 216, all over 4. Okay, so we end up with this piece, 16 plus or minus square root of 40 over 4. Well, that's actually can be simplified even more. So let's take a look at it. 16 divided by 4 plus or minus square root of 40 divided by 4. All right, well, 16 divided by 4 is actually, 4 goes into 4 one time, 4. So we're going to say 4 plus or minus square root of 40 over 4. But square root of 40 over 4 can be reduced. Square root of 40 is the same as square root of 4 times the square root of 10. And I know square root of 4 is 2 square root of 10 over 4. And 2 goes into 2 one time, 2 goes into 4 two times. So I end up with my final answer being 4 plus or minus square root of 10 over 2. So x equals. All right, and I know I'm going to get some words right there. So that's it in simplest form. So here's your answer. All right. Next. Okay, you can also check this by solving by completing the square. So I'm going to do it real quick for you on this one, then I won't do it on the others quite so fast. Okay, so when we solve by completing the square, we start with our original equation. And the very first thing we want to do is go ahead and subtract 27 onto both sides, minus 27. So I end up with 2x squared minus 16x plus something is going to equal negative 27 plus something. All right, so when I start to factor this next set, I notice that there's a 2 in front here that I can factor out of here. So I'm actually going to factor out a 2, and that's going to leave me with x squared minus 8x plus some number is going to equal negative 27 plus some number. All right, so what is that sum number going to be? Well, it's going to be negative 8 divided by 2 equals negative 4, and negative 4 squared equals 16. So I'm going to add 16 to both sides. But actually, I added 2 times 16, which is actually 32. All right, so once I have my 32 there, now I can I can factor this now. I can say what two numbers multiply together to get 16, add together to get negative 8. I know that's going to be x minus 4 times x minus 4, because here is my negative 4, and all that's times 2, and that's going to equal 5. So I actually have 2 times x minus 4 squared equals 5. All right, so let's divide our 2 by both sides. So I have, I'm going to start over here now, x minus 4 squared equals 5 over 2. So I haven't gotten to my x alone yet, so I've got to square both sides. All right, and I end up with x minus 4 equals plus or minus square root of 5 over square root of 2. Now remember, I can't have a square root in my denominator here, so I'm going to have to multiply both the top and the bottom by square root of 2. All right, and so square root of 2 times square root of 2 equals just 2 over square root of 10. Okay, so now we're getting close. So let's add 4 to both sides, plus 4. So we end up with x equals 4 plus or minus square root of 10 over 2, which was our original answer on the other page. Okay, and here it is just written out nice and neat for you. Okay, next. All right, here's one for you to try on your own. See if you can do this using the quadratic formula. So turn your video off for a second and give it a try. All right, hope you were able to complete that. Let's do it together now. All right, so the first thing we want to do is figure out what our A, our B, and our C are. And you can see that just whatever the coefficient is in these three places. All right, and the next thing we want to do, remember, since it says find the zeros, we're trying to find out what y is going to equal. Okay, what x equals when y is 0. So we're trying to find what does x equal when y equals 0. All right, so there's our equation set to 0. The next thing we need to do is write the quadratic formula. So let's do it again together. I really want you to get this memorized. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, there we go. So now let's fill it in. We got to substitute everything. So we're going to say x equals negative, and b is 3. 3 plus or minus the square root of b squared. So that's going to be 9. Minus 4a is 1. C is 7. All over 2a, and a is 1. Okay, there we go. Now I'm just going to I've already done this in advance a little bit. So here we have x equals negative b plus or minus the square root of b squared, 9, minus 4ac. Okay, and I left out a negative 7 there, so that gives us a positive 28, because 9 minus a negative 28 all over 2a. So now we just have to simplify that a little bit further and write it in simplest form. So we have 9 plus 27 is just, or 28 is 37. So this one's pretty easy. Negative 3 plus or minus square root of 37 divided by 2. Okay, and again, you can do the completing the square. I'm not going to do every single step for you this time, but remember, we're going to put the 7 on the other side, and then we're going to complete the square. And when you do all of that, you end up with the exact same answer. So if you'd like to put the video on pause and look at each of those steps a little more carefully, you're certainly welcome to do that. All right, so next. Here's another one for you to try on your own. Turn the video off and give this one a try. All right, once again, we're going to solve for, get our A, B, and C, and those are just the coefficients in front here. So A equals 1, B equals -8, and C equals 10. First thing we want to do is set f of x equal to 0. So we're saying y is equal to 0. So we want to know what is x when y is 0. So here's our equation set to 0. Next, all we have to do is go ahead and write out the quadratic formula. Again, I want you to have it memorized, and you will write it out every time you do a problem. So that each time, if you'll sing it in your head, you don't have to sing it out loud, but at least sing it, you'll get it memorized pretty quickly, okay? So here we go. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, there we got it. Now we're going to substitute for our a, b, and c. So again, x equals -b, which is -8, plus or minus the square root of b squared. So b squared, -8 squared, is +16, minus 4 times a, which is 1, times c, which is 10, all over 2a times 1. There we go. All right, so now just to simplify that, I'm going to just go ahead and do it. So here's our +8, because we had a negative and negative gives us a +8, plus or minus, and I put that in wrong. Let me get that fixed. Okay, b squared, 8 squared is actually 64. That's, oh goodness, 64. Okay, 64 minus 40 all over 2. So that's going to be 8 plus or minus square root of 24 over 2. And now we have to write that in simplest form. So let's take a look at that real quick. It's actually going to be 8 over 2 plus or minus square root of 24 over 2. All right, and so 2 goes into 2 one time, 2 goes into 8 4 times. Let's look at square root of 24. That I know is the square root of 4 times 6. So I'm going to say square root of 4 times square root of 6. I know the square root of 4 is 2. There's nothing for our 6, so it'd be 2 over 2, and our 2's can cross out. So in the end, our answer is going to be 8 plus or minus 2 square root of 6 over 2. And since these two crossed out, it's actually 4 plus or minus square root of 6. So here's your final answer right there. And once again, you can solve by completing the square. Here's the steps for doing that. If you'd like to turn your video on pause and take a look at each of those steps to make sure you know how to do it. But I am telling you that if you did it, you'll end up with the exact same answer. Okay, here's another one. Now this one, notice that this says we're going to solve the quadratic functions with complex zeros. Now remember what a complex number is. Remember, a complex number is when we have a plus bi, and that I stands for I equals square root of -1, and it's an imaginary number. So we're actually going to solve for our zeros with imaginary numbers. So this is going to be for parabolas that look like this, okay? So let's get started on it. So the first thing we want to do, again, is just find our A, B, and C. So I didn't write those out for you this time. But again, we want to set f of x equal to 0. So y is equal to 0 because we want to find out what is x when y is 0. All right, so let's keep going here. And we want to write out our quadratic equation, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, and next we're going to substitute all of our letters in. 3 is our b, -b, plus or minus 3 squared minus 4 times a times c, all over 2a. So there it is. And now once you simplify it, we end up with this, and they left out the plus and minus there, or I did. All right, and finally, we're going to write it in terms of I. So let's talk about what happened here. So we had 3 over 8 plus or minus. Okay, so notice 9 minus 32 is actually negative 23. Okay, so remember, there's no two numbers that can multiply together to get us negative 23. So negative 23 is actually the square root of 23 times I. Now, I went ahead and separated my 8s over each of the numbers. You could certainly have it like this too, and I would accept that, or I'll accept this way. Either one of those are fine. Okay, so when you come up in under here, if we have a negative number, we have to change that to an I, but everything else stays the exact same. All right, here's another one for you to try out on your own. So turn the video off and give it a try. All right, so it says find the zeros of g of x equals 3x squared minus x plus 8. All right, so the first thing again, since we're finding zeros, we're going to set y equals to 0 because we want to find what is x going to be when y equals 0. All right, so the first thing we do is that. The next thing we want to do is write out our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There you go. All right, now we're going to substitute our a, b, and c. So remember, this is our a, 3 is our a, b is negative 1, and c is 8. All right, so negative 1, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and then when we simplify that, we actually end up with 1 plus or minus the square root of negative 95, and all of that is over 6. All right, so we see that negative 95, so that's going to be an I, and so we have to just rewrite it. 1 over 6 plus or minus square root of 95 over 6I. Okay, so here is our final answer. Wondering why. Don't really think this negative is supposed to be there. I think that's a typo that got in there. So let's, there's your answer. Okay, now we're going to talk about this part inside our square root. B squared minus 4AC. This is called the discriminant. It is part of the quadratic formula that you can use to determine the number of real roots of a quadratic equation. So depending on what happens here, we're going to know what our quadratic equation looks like. Did it cross twice? Did it hit the x-axis once? Or no times? Okay, so that's what our discriminant is going to help us to find. So let's see what happens. When b squared minus 4ac is greater than 0, that means it's 1, a positive number. That tells us we're going to have 2 times when y is 0, we're going to have 2 points on our parabola, or where the parabola crosses the x-axis. If I have b squared minus 4ac is equal to 0, that means it's only going to hit 1 point on my x-axis. And if I have b squared minus 4ac is less than 0, that means it's negative number. Then that tells us that we're going to have 2 distinct non-real complex solutions. All right, and our parabola is going to be up above like this. So make sure the equation is in standard form before you evaluate the discriminant. So it has to have ax squared plus bx plus c. Okay, that's the form it has to be in so that you can use this b squared minus 4ac. Here's an example. Find the type and number of solutions for this equation. All right, so first of all, notice that this equation is not written in the standard form. So the very first thing we want to do is rewrite it into standard form and set it equal to 0. All right, so once we've done that, let's figure out. So we have b squared minus 4ac. So let's look here. A was 1, b is negative 12, and c is 36. So all we have to do is fill those in to the appropriate place. Here's our b and our a and our c. And when we do that, we get 144 minus 144 equals 0. Okay, so when we get 0, that tells us that our parabola is going to be hit our x-axis just one time. Okay, so since it's equal to 0, it tells us the equation has one distinct real solution. That means there's only one place when y is 0, there's only one x, okay? And it's right there. Next. This one again, we're going to take a look at this one and find out the solution. So first thing we have to do is get it written into ax squared plus bx plus c format. And then we'll set it equal to 0 because we're solving for zeros. So there it is. Our a is 1, our b is a is 1, b is negative 12, and our c is 40. All right. And so there's our discriminant b squared minus 4ac. We're going to substitute our a, b's, and c's in there. And when we do that, we come up this time with 144 minus 160 equals negative 16. So that tells us that b squared minus 4ac is less than 0. So when it's less than 0, what that actually tells us is our parabola is going to be up here. So our parabola is never going to cross the x-axis. But our answer is going to be the equation has two distinct non-real complex numbers. Remember we talked about the axis, this is our regular axis and this is our imaginary axis. All right, so it's going to be in the complex solutions, two of them. All right. Finally, a third one. Again, we want to write this into ax squared plus bx plus c format, and we want to set it to equal to 0. Okay, and here it is, and we see that we're going to set up our b squared minus 4ac and substitute all of our letters in. So this is a, this is b, and this is c. So we fill them in, substituting. When we do that, we get 144 minus 120, and we get 24. That's a positive number. So b squared minus 4ac is greater than 0. And when it's greater than 0, that tells us that our parabola is actually going to cross our x-axis in two distinct places. All right? The equation has two distinct real solutions. Okay, try one on your own now. All right, hope you were able to get that done without too much problem. First of all, we want to set it up into the x squared minus 4x plus 4, so it's in the correct standard form. And once we've done that and we've identified this is our A, B, and our C, then we can substitute everything for b squared minus 4ac. And there's the substitution for all of that. And we end up with 16 minus 16 equals 0. If it equals to 0, that tells us our parabola just hits the x-axis in one point. All right, so that tells us that the equation has one distinct real solution. All right, here's another one for you to try on your own. Again, rewrite it into the standard form. X squared minus 4x plus 8. So this is our A, this is our B, and this is our C. Our discriminant equation is b squared minus 4ac. All right, so we substitute our A, B, and C in, and we end up with 16 minus 32 equals negative 16. Negative 16. So when b squared minus 4ac is less than 0. That means it's a negative number. Remember, that's going to be, it's actually that negative 16 is under this square root. Okay, so that tells us that this is going to be an imaginary number. All right, and so our imaginary set is happening up here, where this is x and this is our imaginary axis. So that tells us that we're going to have two distinct non-real complex numbers. Okay, so remember this b squared minus 4ac, that's part of our quadratic equation. Let's go through it one more time. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's why this is a negative 16, and that's what makes this in the imaginary, because it actually ends up being an imaginary number, because we can't have two numbers that multiply together to get a negative number. One more for you to try out on your own. First of all, set it into the standard format. X squared minus 4x minus 2. Remember, this is a, this is b, this is c. Our discriminant is b squared minus 4ac. Substituting in our a, b's, and c's, we get 16 plus 8 is positive 24. So that tells us our parabola is going to cross in two distinct places. Because it's larger than 0, the equation has two distinct real solutions. We're not having to deal with any imaginary numbers. Okay, and once again, one little thing for you to remember, you've seen me drawing these parabolas a lot. The graph shows related functions. Notice that the number of real solutions for the equation can be changed by changing the value of the constant c. So in this equation, x squared minus 6x plus 7, we actually have 2. All right, here we have x squared minus 6x plus 9. We only have 1 place. And then the last one, x squared minus 6x plus 11, now it ends up being in the imaginary area, okay, because it never really crosses. Okay, and that is the not quite the end. These properties of solving quadratic equations and when to use them, okay? So for graphing, it's only appropriate to use graphing when you're just going to approximate the solutions and the number of real solutions are needed. All right, so we don't really need to graph these equations very often unless the instructions just tell you to. But if you were just looking at it, that was not very... It's not a very exact answer just by looking at something like that. Okay, another way we could deal with quadratic equations, we could factor it. Okay, and when would it be appropriate to factor it? Well, when c equals 0 is a good time, and when the expression is easily factorable. So if you look at it and say, oh, I can easily do that. So like I look at this one here and I say, two numbers that multiply together to get 3, add together to get 4. That's really easy, 3 and 1. Okay, so factor it the easiest way. Always try your factoring first here and see if you can do it. All right, if you can't factor it, then we could try using the square roots, and you could do that if the variable side of the equation is a perfect square. Okay, so if you see some perfect squares around here like this, we can easily just factor it using the square roots. All right, here's a couple of other ways that you've learned. So you've learned to complete the square. So you can do that when a equals 1 and b is an even number. Okay, because all the times that we did it, remember we had like 8 divided by 2. That was really handy. 6 divided by 2. That was really easy. If you had a 5 divided by 2, you can still do it, but it's not quite as easy. And sometimes it's easier to just use the quadratic formula. Okay, and let's just sing it one more time so make sure that you know it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, some of you may be sick of hearing me sing that, and sorry. Hopefully some of you have learned it now and you won't forget it. All right, so I might even give you a pop quiz on that in the class tomorrow. All right, so I hope you learned something great today. And no matter which method you use to solve a quadratic equation, you should always get the same answer. So you can check lots of different ways on that. And that is the end of this lesson. And I hope that you have a great day, and I will see you soon. Bye now.